we will talk about the image compatibility to make sure the container application can work harmoniously with the host. We have assumed write once, run everywhere in Linux. Yeah, and the container almost reached the dream that package once and run everywhere. Usually, the container seems to be portable from one host to another host, but it's not always like this, because container is still a process running above the operating system. So what a process has a dependency on the operating system and the hardware, the container also have a similar issue and challenges. So what's the compatibility? Compatibility in the dictionary, it means work successfully, not just it can start and run. It means you have to work very successfully and process the business logic correctly. So for work successfully, for different container application, it has a different meaning. There are several dimensions we have to consider. For the first category of compatibility is the hard requirement. That means the container application has very strict requirements on the operating system and the hardware and the other components. If the host miss this kind of components, the container cannot start and cannot run. For example, some application may require specific CPU features. For example, for the vector optimization. And also some application has some dependency on specific kernel module and drivers. For example, for the AI workload, if you have an application which use the CUDA 12 version, then you have to find a hardware which shipped with the driver greater than 525 point, yeah, like so. Otherwise, if the old driver was installed in the host, the AI workload cannot run very well. And another example is that we know that KubeVirt to run the virtual machine inside a pod. For virtual machine, it has to be supported by some virtualization component, for example, the KVM or other hypervisor supported technology. So if Node A have a KVM installed, yes, it can work. But for other node, if there is no KVM module, the KubeVirt cannot run virtual machine in this node. Except the hard requirement for some mission critical application, just run is not enough. It has to meet the performance metrics. So especially for some real-time or near real-time application, not only the performance, but also some response and reliability and so on. It must meet this kind of demand. Otherwise, the application cannot meet the SLA. It's also incompatible. So we have some example for this kind of compatibility. For telecom application, they have very strict service level agreement. For example, for caps means the call attempts per second. It's not like usually request per second. For request per second, it's just some request handling in 1 second. But for call attempt per second, you have to maintain the call during the evaluation. For example, you make a phone call, except for the standard processing, you have to maintain the call handling. Yeah, it will last maybe 20 or 40 seconds or several minutes. So for the application may have a very strict requirement on the network interface card. If one network interface card can ensure all call attempts can meet the latency requirement. For example, the latency requirement must be less than 50 milliseconds. Okay, if you can reach 5,000 call caps and all requests can be processed within 50 milliseconds, okay, it meets the SLA. But for another network interface, if the latency will larger than 50 seconds. For example, we tested one network interface. It can only reach 80 milliseconds. So for this kind of network interface, it's not compatible with the application because it will violate the latency requirement. So for this kind of application, if you run the application on the incompatible network card, yes, it can run, it can be demo, but you cannot put it into production. For example, if you make a phone call, some other ones talk to you, you cannot hear him clearly, then you will complain about the service quality. So for telecom application, it's not just a one dimension requirement, not only for latency, for the caps, you have to also considering the availability. For example, in IT, it usually you have just meet 3.9 availability, but for telecom application, you have to realize 5.9. 5.9 availability means only 5 minutes downtime in 1 year. But usually we know if there is some failure, it usually will break 5 minutes downtime. That means for telecom application, you have to take it very, very carefully. Otherwise, it will violate the 5.9 service availability. And except for the 5.9 service availability, there are also some other service require very, very low latency. For example, for the interactive gaming, for the mobile wireless network, it has to be provide 10 millisecond guaranteed latency. And for remote control, for example, if you have a robot, you want to control it for the end-to-end latency, it should be less than 5 milliseconds. So for mission critical application, it will produce a lot of requirement on the hardware and operating system. Yeah. So the next, we're Marcin.
Test. Sorry to the camera guy. You can hear me well. So following examples provided by Joe about compatibility context, let's talk how people are doing this today. Defining and checking compatibility. So first of all, documentation, right? If it exists, it's great. But it's very hard to make some automation based on that. And people provide documentation in different ways. Then we have attempt to launch, and in case of failure, read the logs. This is one of the most thing I saw in the industry. Like we have some Kubernetes cluster. We just get some third-party applications. And in order to check if image is compatible with the nodes, people just trying to run this on the staging environment and see if it fails or not. If it fails, they try to reconfigure the staging environment and the production. Very, very often I see that in the industry where their images have very hard requirements against hardware operating systems. And then we have annotations. That already provides some information on the image side. It's a good attempt for some kind of standardization. HPC community tried to standardize this a little bit for them. They came up with this idea of annotations that would describe operating system, hardware, and so on. But we have to do much better than that because we have to take this outside of HPC and we have to bring this to everybody, to the entire ecosystem. So who knows what is OCI, Open Container Initiative of You? So for those guys who doesn't know, this is an organization that governs image specification, runtime specification, and distribution specification. So it tells you how to build image, how to run them on the host, and how to distribute images. So for example, Containerd, Podman, Docker, they follow container runtime spec and registers distribution specification and other tools to build images, basically how you can build them and support in general. So today, OCI doesn't have this compatibility standard, and we believe this is a problem. Because once we have this, we make much easier supportability. So once we are able to provide this information on the image side, we will be able to provide more information to sysadmin on what to expect, especially crucial if you are having dedicated clusters and consuming third-party applications. And if you have like hundreds of these applications, it's better to make some automation based on that, so you are able to consume this in more better way, right? Instead of all the time looking into documentation, trying to run this and see what's failing. You will be able to also group applications, configure clusters based on that, and validate hardware and operating system in terms of cluster expansion and cluster upgrade, and also fail fast. This is about this attempt to launch in case of failure, read the logs. You can have entry checks quite easily, right? If you consume some metadata for compatibility, you can have some tool that will validate. You will have entry step to validate if node is okay with the image or not. So last year, we went to OCI and we said, we would like to work on this kind of standardization, make it officially under OCI. So our scope was to deal with this host OS and hardware requirements. Initially, we wanted to support Illumos, Linux, and Windows, and final list of supported fields was to be figured out by the working group. And finally, appropriate solution, some kind of POC should be implemented there. There is a link to the proposal. I recommend you to take a look. This proposal was reviewed by technical oversight board of OCI. If they had to evaluate if this is something that makes sense to work on or not. But successfully, we were approved, and we were able to get good amount of companies that are involved in this process. So there was Huawei, NVIDIA, Illumos, OKD, Intel, SUSE, HPC, and Docker, and good amount of owners. And I wish all owners on this list were active, but unfortunately they were not. Still good. We still had good amount of people working on that. And as a group, we had 3 high-level use cases. First, more granular image selection. So for example, if container runtime speaks some image manifest, we would like to provide more details onto images to make better choices. Then improve container scheduling, not only for Kubernetes, but other orchestrators as well. That's why this is under OCI, not, for example, under Kubernetes. The first attempt was under OCI. And then we have cluster provisioning that there are already some operators exist that are able to reconfigure operating systems and so on. So we could use it for automation, but not only for automation, but that would be also good. Some good tools we could implement for sysadmins as well to help them to do that. So basically, we had 2 ideas how to do it under OCI. First one is to extend the image spec, and the second one was to build a separate specification and build artifact. More about that in a second. So here we have 2 manifests, 2 images with 2 different architecture. So how it works today, container runtimes, when they pick appropriate image, they take a look into platform object, architecture as a variant. Here you have this. And they compare what they have on the node with this, what's on the image index. And based on that, they pick the most fitting image. But what's interesting in here is when you have list of index, if you have list of manifests in the index, usually it works that way that first image that fits will be pulled and the algorithm will stop checking the others. So in order to provide more details, we thought to introduce platform compatibilities and use platform features that has been there in the spec for some time and haven't been used, never basically. So we thought to enable that finally for CPU features and introduce platform compatibilities to describe any requirements that people have against their images and so on. So it would work that way. If you have manifest A with only OS architecture and variant, and you have manifest B with the same OS architecture and variant, but if you put more details into manifest over platform features and platform compatibilities, then manifest B will be promoted higher than manifest A in the list, in the order, right? Quite simple idea and with backward compatibility, but there were some issues we are still discussing, and there is another proposal that we could solve that. It's to introduce a similar structure, similar field in the image spec, which is platform prefer. It's also a map string, as you can see. Similar idea of platform compatibilities, but instead of relying on the order with this, like how much you information put in there into compatibilities, you would put weights. However, the weights is not a part of the image spec. That would be something that has to be implemented by container runtimes. And for example, you could influence the image selection by adding appropriate weights to the container runtime configuration. So yeah, that's how it would look like for the image spec. But with this, we have some issues that we're discussing under OCI, because we don't want people to dump the host configuration and put into image index. That would be like overkill, right? That you have a lot of metadata in the indexes. People were quite afraid of that. So currently we are investigating this extension of image spec, mostly in terms of image selection. It could be also used for compatibilities, in my opinion, but if you give something to people, you can be sure that they will over-abuse that. That's the thing. So we have to be quite smart in here about this, what we are doing. And then finally, the idea of an artifact. So what we want to do here is just to introduce a completely new specification alongside of image spec, container runtime spec, and distribution spec. So as you can see here, compatibility is quite simple. You have list of labels, you have some tags, so you could have, for one manifest, two different sets of requirements, because if you are running your images on different CPU vendors, you might require different kernel modules, different kernel configuration, or rely on different CPU features, so it's kind of related. And the whole compatibility spec would be attached to OCI artifact, which is a separate entity, and it would point to the images. However, OCI is all about stability. They didn't like this idea initially. They didn't like to introduce a new image, the new standard alongside the already existing standards right now, right? They want us to prove it, that this is something useful and will be used by users, because if you introduce something under OCI, before you even release a new tag, which is a release candidate, you can have cases where people will already implement that. And when you decide over release candidates or releases that, okay, I don't like these features, we want to take it out because maybe it was badly designed, people will complain, man, I already implemented that, why are you taking this away? So it already happened a few times under OCI. And as you can see, the good example how they work is, look at how often they release new versions of the specifications, right? Right now we have 1.1, which took them, if I'm not mistaken, 2 years or something like that. So this is, OCI is all about stability, which is, they have reasons why they are so slow, right? Because there are so many different products that's relying on that, so it's justified this way. But we don't give up on OCI, of course, but in order to prove this is something useful, this compatibility idea, we decided to knock to NFD, Node Feature Discovery project of Kubernetes. And they already providing nodes features labeling. And they have quite good community, and we can get some feedback immediately about this, what we are doing in there. And NFD maintainers know the problem with image compatibility. Eduardo, who is one of the maintainers, is part of HPC community, so he knows the pain with that. We split it into two phases with image compatibility POC. First one is, as I said, just to use NFD labels keys to describe container image requirements. Then we want to create some kind of notation that will describe values, including list of ranges. So what I mean by that, because when you are running NFD worker, you will get some labels like, I don't know, it will annotate your nodes with specific literal value like kernel version 5.15. But you need to describe ranges on the container image side, right? So you will have to say, I don't know, my image is running with kernel 4.15 till 5.15 or something like that. It's a little bit different mindset that most of community today has, because people assume containers for them will work everywhere, which is fine, right? But if you have specific requirements against hardware and some features of operating system, then you cannot make this assumption. And then we would like to use OCI artifacts, as mentioned before, would be Kubernetes, probably NFD type. And we would like to allow to verified node compatibility, including nodes that are not part of Kubernetes cluster yet. So simple tool to validate nodes based on compatibility metadata. And phase two would be to enhance pods node selection based on this compatibility. So let's take a look at the pictures. Here would be like, I have image author owner that creates specification to describe its images, and wrap this around artifact, attaches to images, and push to OCI registry, any registry that supports artifacts, I don't know, Docker Hub or whatever. I think they support artifacts, right? At least. And then we have admin that would be able to use NFD client to fetch NFD artifacts and validate the nodes. That would be the phase one, very simple. And phase two is mostly like we still try to figure out how this would work with pods. Because instead of NFD client tool, you could have mutation webhook or a scheduler plugin. Then you would be able to influence node selector of the pod. But here we don't want to put all the compatibility metadata that resides in the artifact to pods, because you would have a lot of labels there. So we thought to use node feature as custom resources of NFD, that you have some kind of requirements, and NFD will do its magic and generate and annotate all nodes that fits the requirements with one label, and you could use one label to use for node scheduling. Basically, that's it. I was talking about that at Kubernetes Contributor Summit and at KubeCon, so the feedback was quite positive, and I'm wondering about your opinions. If you have any questions, what do you think about this incompatibility problem and how you deal with that?
Yeah, thank you so much. This is the first talk I've heard about this topic, so I think it's really, really exciting. Do we have any questions? Remember to post. So I was wondering, like, is it something that you needed as part of your work at Huawei?
Yes. Yeah, this is what we need, not only at Huawei, but the whole telco industry, and other industries as well, like, I don't know, edge computing, telco, high performance computing, all these industries where we need this, where images require something specific from hardware or operating system, need that. So that would be something useful. We see that with some kind of delay, at least from my observation, because telco is not moving right away to new things, right? It's not moving to containers once they appear. You need some time. It's all about stability and so on. Now you see the process where telecommunication is moving to containers from virtual machines. So yeah, that's why basically this topic, I think, pop-ups now, because people are starting moving to this from virtual machines.
We have a question about what's the reason to attach that information about, for example, driver versions to the image. NFD allows to specify requirements already via pod resources.
But pod resources Sorry, can you the first? Why would you? Can you repeat the first part
What's
of
the
that?
reason to attach the information about the driver versions to the image when you can
Okay.
already do that via pod resources?
Well, first of all, we want to have on the image side all the requirements that image has. So if you have any driver that has been tested with the image and you are sure it's working in terms of different compatibility contexts, you have this information provided by the author in one sources. If you put NFD, from the NFD resource point of view, or pod resources, or over pod spec, this kind of requirements, it's not coming from the author of the image or the person who knows the stuff the best. Because if you would do that way, you don't change anything. You can run as it is. I mean, I can put to pod spec anything, any requirement, right? And kind of, I lose the information from the image author about about the requirements of this stuff, right? So to make it more clear, if I have image A that is consumed by N vendors, each vendor would have to put this himself, learn himself about this requirement and put to the pod spec. Instead of, we want to leverage this, that image authors are able to attach this information directly to the image, that later you don't have to put yourself this information to the pod spec. You could have this auto-generated.
Yes, additional comment that because it's different lower to provide the information. For image author, usually it's the developer. For developer, when they package the application, they know what the compatibility the application required. And but when the application delivered to different customer, the administration of the cluster is not the one who developed the application. So the administrator of the cluster need a way to know what the compatibility for the image. So it's the different lower in the from the source code to the production. Yeah.
We've got more questions. Are there plans to also support image selection, like with manifest lists with the NFT POC?
No, because this is a different topic. It's on a different level. We have at the same two efforts. First one is to improve this image selection under OCI. So we are working on some prototypes with container runtimes and how to influence image spec to make better the image selection, and the other effort is with NFD compatibility. If you get to the, sorry.
They don't see that.
If you get to the high-level use cases, more granular image selection would be part of container runtime and image spec. Improve container scheduling, cluster provisioning. This is NFD POC right now, and eventually we plan to get back to OCI to create kind of standard out of that.
Another question is, we usually build images with specific hardware in mind and schedule workloads on those nodes. Why would we do it the other way around?
Well, yes, I mean, you build these images with specific hardware in mind, that's true, and schedule workloads on the node, but we have different scenarios. If you, for example, running some I don't know, high-performance router that a lot of telco vendors are consuming, that you want to put these requirements, what my router is requiring, what kind of hardware is certified for that or so. So you have to keep in mind you are not always the author of the image, or it might be a different company. So the consumers also can be different. It's not around one organization and so on. So you have to pass somehow this information about this specific hardware in mind, right? That the thing is that company A can provide something to company B, and you have to pass somehow this information in a standardized way.
Additional comment that for the developer of the application may be delivered to different customer, maybe 15 customers. For 15 customers, they have different hardware. So you have to build the compatibility from the developer perspective. But what kind of hardware and the operating system can be compatible with the image. It's not can be pre-decided by the developer. Yeah.
Yeah, and people are not always building containers images, for this specific. I don't know, for specific GPU model, right? It can be more generic and be tested with some specific stuff, and this can be also put in the image compatibility stuff.
One question that I also had is as your solution is still in progress, what does it need to be finished?
That's a good question. We are having a pull request with proposal under the NFD repository. I'm working right now in some prototype. So I would say, first of all, we need to find agreement about the final scope of this prototype. I already had meeting with Marcus and Eduardo from NFD. They basically were kind of positive about this. So we need to find a common ground with the scope, and we need to, basically build that prototype and see what do we do next.
Yeah. But now is also the perfect time for you to get opinions from the audience, I suppose. Yeah.
More people join, more faster we will reach the goal.
One more question is this intended to work with all types of node features or only CPU instructions?
No, on all types of node features.
Okay, and the final question is, will this enhancement influence the speed of the scheduling mechanism of a new pod?
That also depends the way how you are doing that. If we, for example, yes and no, I would say, because if we implement this as a scheduler plugin, maybe, I mean, can we make this more question precise in terms of this device's discovery, or what do you mean by this? Because for me, this is too generic question.
Maybe we can chat about it during the break. So if you ask the question, you can come chat to our speakers.
Okay, we can talk about that.
Thank you so much. Give a round of applause, please, to Marcin and Joe.